Hello again. So now we are exploring surface integral with the second method, method 2. Alright, and method 2 is given by as equivalent to my integral of my magnitude of my r of u cross r of v. Of course, dA at the back. So remember, just picking up from the same example one earlier in method 1 in the previous video. So we want to find surface area of a sphere. Okay, how do I even draw a sphere? Alright, a sphere anyway. So surface area of sphere with radius a. So let's explore this method here. Again, for second method, this is where we use parameterization, isn't it? So when we talk about parameterization, first of all, we are talking about sphere. So remember earlier in the first ever video in surface integral, that basically means that my r will be of my theta, and well, this will be the components that we have for sphere, right? So how do I express x in my spherical coordinate? That would be r sine theta cos phi. Alright, I can just replace my r with a, right? Because this is of radius a. Okay, I'm going to replace it now itself. And y will also be r sine theta sine phi. Again, my r is a. I'm replacing this with a. Z is r cos theta, which then becomes a cos theta. Alright. First of all, in parameterization method, which is method 2, remember we are actually given my r. So we are going to write down the vector, unlike what we have in the first method, as xi plus yj plus zk. And what you do is just basically replace this x, y, z into this form here. Alright. Of course, depending on whether it's spherical shape or cylindrical shape. This one applies to spherical shape. This is what leads me to a sine theta cos phi I plus a sine theta sine phi j. I'm going to continue it here. Plus a cos theta k. Alright. Remember next, what do you have to do? So recall this form here. Recall this form. So it basically means that I will get a dr over d theta. Alright. So when you get a dr over d theta of this expression, because that's why we earlier find our r vector, because now we are going to differentiate it with respect to d theta and d phi. Alright, and then after that we'll do a cross product of it later. So if I differentiate this according to theta, so this phi then becomes constant, a becomes constant, yeah. So if I differentiate, let's start with, okay, this is d theta. So if we start with d theta, then this gives me a cos theta cos phi I plus a cos theta sine phi. So you can see, right? Actually, differentiation of sine theta is just cos theta. And minus a sine theta k. Alright, differentiating cos give me negative sine. So this is what I have for my dr over d theta. Let's start with dr d phi then. Same thing goes. I have negative a sine theta sine phi I. So see to that I'm differentiating cos phi, which gives me negative sine phi. I'm just putting this negative here. Plus a sine theta cos phi j. Alright. And what about my k? Do I have anything? Basically, it would just be 0, yeah? Because I do not have any component of phi here. And next, now, I'm going to get the cross product. So that would be dr over d phi cross dr over d theta. Which then leads me to, I have my I here, I have my j here, I have my k here. Cross product. So remember, yeah? Still recall cross product. So I, j, k. So I'm going to put each of this element, coefficient of this element of its I, j, and k to its equivalent part here. I missed out this j part here earlier. Okay. So let's start with the d phi. So for d phi, I have this, right? So this gives me a negative a sine theta sine phi. I'm going to have to squeeze this in. A sine theta cos phi. This is 0 for my d phi here. Alright. Dr d theta, I'm going to place these at the first, second, and third place respectively. This now gives me a cos theta cos phi, a cos theta sine phi, and negative a sine theta. Alright. Now, you have to perform your cross product. For cross product, if you remember, so let's put that with I. Alright, so what happens is that if you can't really remember, every time when you're, let's say I'm dealing with I, so this is, it goes according, so you cover the row and the column in which I resides. That leaves you with these 4 elements. So you get the determinant of it, basically you just cross multiply. Alright, the left diagonal part multiplication will minus the right diagonal one. Okay, so now this will lead me to negative a square sine square theta cos phi minus 0. Alright, minus j, very important. I and minus j, this is part of the formula of your cross product. Again, on this side here, therefore I'm going to multiply this with this and minus this with this. So I will have a square sine square theta sine phi minus 0 again, right? And lastly, plus k. Plus k, that will be negative a square sine theta cos theta sine square phi plus a square sine theta cos square phi. As interesting as this gets, so you can see that I have sine theta cos theta sine square phi, sine theta cos square phi. So let's look at the k component for a little bit. You can see that this part here is exactly the same as this part. So say I can also rewrite this k part here. I'm just gonna circle it out. Alright, I can rewrite it as negative a square. Well, this is k here. Negative a square sine theta cos theta. And then guess what? If I put a minus here, then this leaves me out with sine square phi and plus cos square phi, right? And what does this tell you? Remember again from trio identity, this is actually equivalent to 0. Sorry, equivalent to 1. Alright, so when this is 1, then it just leaves you with this part here. Alright, sorry, earlier on this part, this is supposed to be a minus. Alright, remember from this k here, cross determinant. Oh, this is, I get a minus at the front part because of the negative sign, and then minus this part. So that's why minus minus, when I factorize this is negative a square sine theta cos theta. Then I get sine square. And when this is minus, I just put a plus here. That gives me 1. Alright? Tiny bit of correction there. Okay. So if I rewrite this again into its nice form, what do I get? I get an I of negative a square sine square theta cos phi minus j of a square sine square theta sine phi plus k. I'm just rewriting this again so that it becomes nicer. Alright, so what is this expression that we just got? Remember, if I just scroll this back up, this is actually the cross product of my dr over d phi cross dr over d theta. Alright, if you recall again, if I just scroll this up a little bit, on our formula here, it basically requires us not to just, after getting the cross product, we're supposed to get the magnitude, yeah? So the next step for us is to get the magnitude of this cross product, okay? Which I am going to write it as the double vertical lines here. Theta. Alright. So in this case, to get the magnitude, again, square those up and get the square root of it. Alright. I'm not going to write the horizontal line here, but take each component individually. Sine power 4 theta cos square phi plus a power 4 sine power 4 theta sine square phi. This is a phi here. And plus, I have no space here, so I'm just going to continue it here, yeah? Plus a power of 4 sine power of 2 theta cos square theta. So see, to that I have this and I have this power of 4. I'm gonna simplify it. So the first and second term here will then be a cos theta phi plus sine square phi, right? Plus a power 4 sine square theta square theta. Again, this is going to give me 1, which leaves me to a4 sine 4 theta. Alright, and if you notice that I can actually still simplify this, and how do I factorize it? And factorize this like this. Alright, so now I have a4, so this then leaves me to sine square theta plus cos square theta. Again, this is actually 1, which then eventually leaves me with a square sine theta. Now that you have found the magnitude of this, now I found my S. Alright, my S is basically double integral of my magnitude of dot product, okay, and parameterization d phi d theta. And where would my phi go? From 0 to 2 pi, d theta from 0 to pi. Alright, from here I can get 0 pi a square sine theta. Because of phi, well, I don't have any term here, so all this is actually constant. Gives me this one, d theta. Alright, and of course then I will get 2 pi minus 0, which is 2 pi. Alright, 2 pi multiplied by a square, I will get 2 pi a square sine theta d theta. Alright, this 2 pi comes from the product of this, which then leads me to negative cos theta of pi and 0. Alright, so this will give me 2 pi a square negative cos pi minus cos 0, right? Minus gives me a plus. If you have this, so when you have this, you make sure that your pi, if you want to press cos pi, make sure that you actually set your scientific calculator in terms of radian. Alright, else you will have to convert it accordingly, because 2 pi is 360, so pi gives you cos 180. So if your calculator is in degree mode, cos 180. Alright, of course don't forget the negative value. This will give you negative 1. This will give you negative 1. Alright, so after the whole thing, you'll be getting 4 pi a square. Here you go, you get the same answer of 4 pi a square for both method 1 and method 2. Alright, so I guess for method 2, it actually gives you more structure, as long as you actually know because usually it just goes by spherical or cylindrical shape. So from there, if you can actually if you remember each component of your x, y, z, and you know exactly what you need to find, the cross product, magnitude of it, of course, be familiar with integrating it, then you get this. So you can compare this method, which is method 2, using the parameterization method, with the earlier video, which is method 1, and then you see which one actually suits you more and you're more comfortable with. But general idea is that method 1 is more for Cartesian plane, and spherical and cylindrical object usually gets kind of easier to be solved in method 2. Alright, good luck!